Good afternoon, everyone. Myself, P. Priyanka, Assistant Professor from the Department of CSE ML and from St. Martin's Engineering College. Today, I will be discussing about logical connectives in discrete mathematics. Okay, now let me represent one thing. See here. All of us like to draw the diagrams, right? So I would like to show one representation with the help of the diagram. Okay, see here. So this is a tree. Okay, this is a tree and these are the roots. Okay, this is a tree. Usually tree is having a leaves, trunk, roots and fruits. Okay, at the end of the day, we will be focusing on the roots. We will be focusing on the roots and fruits. Right? At the end of the day, we will be focusing on the roots and fruits. So you may get doubt, ma'am is starting with the discrete mathematics subject and she suddenly shifted to the tree. So what is it a tree? Is it apple tree or a banyan tree or a peepal tree? What is the type of tree? Yes, I would like to name it as an engineering tree. I would like to name it as an engineering tree. Now, what is the meaning of a root? Roots are maths plus physics. Yes, roots are maths plus physics. And what are the fruit? Various branches in engineering. So what are the fruits? If we consider an engineering tree, roots are maths plus physics and the fruits are various branches of engineering. What are they? We are very much aware that is civil engineering, mechanical engineering, electrical engineering, ECE, IT, CSE, and these days we are seeing allied branches. So we are very much aware of the maths. So you may question me, ma'am, we are aware of the mathematical methods, calculus, trigonometry, numerical methods. Now what is this discrete mathematics? Yes, let us see. So why discrete mathematics? Now the question arises that why discrete mathematics? It develops our mathematical thinking. It develops our mathematical thinking. It improves our problem solving ability. It improves our problem solving ability. It is important to survive in subjects like compiler design, database, computer security, operating system, automata theory. And moreover, many problems can solve using discrete mathematics. For an example, sorting of integers. When we are during childhood, we use it to play like you have to draw a structure without lifting the pin. Without lifting the pen, you have to draw a structure. Such type of problems and permutations, combinations, and more problems can be solved using discrete mathematics. Finally, I can say that discrete mathematics is the base for CSE. Okay, base for CSE. Now, so what is discrete mathematics? Now the question arises, right? What is discrete mathematics? It is a study of discrete object. Discrete mathematics is nothing but a study of the discrete object. What does it mean, discrete? Discrete means distinct, which is not connected. Discrete means distinct, which is not connected. Basically, it is not a branch of mathematics. It is not a branch of mathematics. We might think that, okay, discrete mathematics means you may start thinking that, okay, this particular term belongs to the maths. No, it is not a branch of mathematics, but in every engineering branch, we can see this particular term. Okay, in every engineering branch, we can see this particular term. Okay, let me discuss one by one. Next, the whole world is divided into two realms, as I said, discrete and continuous. In order to understand that particular term discrete, I said, which is not connected or distinct, we have to see one more term, that is continuous. Let me explain. Okay, what is this? So analog or continuous. Analog or continuous. The opposite term is discrete. The opposite term is discrete. Okay, analog or continuous, discrete. Now discrete. Let me give you one example. Okay, for discrete, number one example, natural numbers. Natural numbers. For analog or continuous, the first example is real numbers. Real numbers. So natural numbers means It starts from 1, 2 and so on. Real numbers means it's a notion, means it consists of natural numbers, it consists of whole numbers, it consists of integers, it consists of rational, irrational. I can correlate real numbers is like a Pacific Ocean, wherein natural numbers is like a lake. Yes or no? Now, if we draw a graph for a natural numbers, it is an x-axis and it is a y-axis. Okay. Let me take the points 1, 2, 3, 4. 1, 2, 3, 4. So if we see x belong to natural number and y also belong to natural number. X belong to natural number, y also belong to natural number. If you see the points here 1, 1, 2, 2, 3, 2, 3, 4, 2, 4. By visual inspection itself, we can say that the points are not connected, right? I mean the points are distinct. Okay, now come to the real number. Come to the real number, x-axis and y-axis. Here x belong to real number and y belong to real number. 1, okay, let me take 1, 2, 3 here also. Okay, here also 1, 2, 3. But in discrete, if you see, there is a sharp transition from one number to the another number. Means if I say first, then it will go to second, next 3, next 4. But in real numbers, we can't see like this. It starts from like 0. He like this 0, 0, 0 0.1, 0 0.2, 0 0.3, 0 0.4, 5, 6, 7, 8, 9, 1, 1.1, 1.2, 1.3, 1.4, 1.5, and so on, so on, so on, so on. By visual inspection itself, we can see that and the log or this graph is a continuous. Okay, continuous. But what about the discrete? It is a distinct. It is a distinct. Okay, this is the first example. Okay, this is the first example. So what is the first example? Discrete natural numbers I have taken, means in order to show the difference between the continuous and distinct, I have given this first example. What is that? Natural numbers. We have clearly seen that the points are distinct, and real numbers, it is a continuous. Okay, next, we are very much aware of the digital clock. See, I have wore the digital clock. Okay, if we see now the time is, okay, 3:16. Okay, now the time is 3:16. Okay, in discrete, it shows very clear that is 3:16. Now, what about analog? If we go to the analog, the clock is like this 12, okay, 6, 9, 3. Yes or no? It is having the hour and minute and seconds. Now, how it will show the 3:16? Like this, somewhere here. Yes or no? Somewhere here. Yes or no? So, the second example is that digital clock. Yes or no? Digital clock. And here it is analog clock. Analog clock. Apart from the digital clock, analog clock, we are very aware of the labs such as a digital voltmeter. Yes or no? In electronics point of view, we are aware of the digital voltmeter, and here in analog point of view, we are aware of the analog voltmeter. Higher digital ammeter, analog ammeter. So these are the examples. Okay, in order to make the things clear, I have taken this example. Right now, I would like to show whatever the examples I have discussed, right? I would like to show through video. Okay, let us see. Let us see the video. Analog input versus digital input. Right? See, this is the analog input graph. Very, it is a continuous. See the numbers also. Continuous numbers 1.5, 2.7 like that. And best examples are the analog thermometer. Okay, analog thermometer, voltmeter and a clock. And if you come to the digital input, the transition is very sharp, 0, 1 like that. The transition is very sharp, off, on. What are the best examples? Switches. Yes or no? These are the best examples for the digital input. Okay, okay, now let me explain one more thing. Now, so the next concept is in the discrete mathematics, logic plays a very vital role. So what is a logic? Okay, what is a logic? In a discrete mathematics, the first concept is a logic. It plays a very vital role. Logic is nothing but a science of reasoning. Okay, science of reasoning. With the help of the logic, we can understand and reason about different mathematical statements. Different mathematical statements, right? See here, different mathematical statements means with the rules of the logic, with the rules of the logic, we would be able to think about the mathematical statement, and finally we can able to prove or disprove the mathematical statements, right? Mathematical statements. Next, what is the purpose of a logic? So the major purpose of a logic is to construct the valid argument, nothing but a proof. Once we prove the mathematical statement is true, once we prove that the mathematical statement is true, then we call it as a theorem. You have been to the several theorems, Pythagorean theorem, Bayes theorem. Yes or no? We have been through the several theorem. So its base comes from the logic. Once we able to prove a particular mathematical statement is true, then we call it as a theorem. Okay, and the theorem is the basis for whole mathematics. Now, very important definition, that is a proposition. Okay, so what is a proposition? Proposition is a declarative statement. Okay, proposition, let me show you. Proposition. Proposition is a declarative sentence. Okay, proposition is a declarative sentence. Understanding? So a sentence that is declaring a fact. Okay, usually in the college we used to hear that tomorrow it is declared as a holiday on the account of Christmas, or tomorrow it is declared as a holiday on the account of Dasra, like that. Yes, so that's a statement. Okay, proposition is nothing but a statement. Okay, so here also see, you can see this example. Hyderabad is the capital of Telangana. It is a statement. Okay, water boils at 100 degrees centigrade. It is a statement. 3 plus 3 is equal to 6. Okay, it's a statement, right? Now, sentences which are not proposition. I said proposition is a declarative statement, right? Now, there are the few sentences which are not at all proposition. What are they? What is your name? This is not a statement. This is not a proposition. I'm questioning, right? What is your name? Second one, x plus 1 equal to 5. It is not a statement. One more thing I would like to tell you. Proposition is a statement which is having only two values, that is true or false. Which is either true or false, but not both. Such type of statements are known as a proposition statements. The another name is a declarative statements. Now see this first one. What is your name? It is not a statement. I'm asking a question. Yes, sir, we can't decide is it a true or false. Yes or no? It is not a statement. Second one, x plus 1 equal to 5. If I place 4 in the place of x, it will become a 5. That's fine. Instead of 4, if I place any other value, it won't be a 5. So we can't tell that it is a true or false. Yes or no? So it is also not a statement. Similarly, send me flower bouquet before 11 p.m. I'm requesting. I can't tell that it is a true or false. He may send before 11 p.m. or she may send before 11 p.m. or she may not send. Yes or no? It is also not a. I request you to please consider me this. This is a request. Yes or no? This is a request. So it is also not a statement. Hurrah! India won the match. This is an exclamatory sentence. Yes or no? It is also not a statement. So very clearly I'm telling you that proposition or declarative statement, it is having a two values, that is either true or false, but not both. Okay, now what is a propositional logic? Propositional logic is nothing but joining two or more propositions. Okay, joining two or more propositions. Let me show you. Joining two or more proposition is nothing but a propositional logic. So Virat is good in playing cricket. Okay, this is a statement one. Proposition is a declarative statement. Sometimes I use a term statement also. Okay, so statement one, Virat is good in playing cricket. Okay, this is a one proposition. Second statement or second proposition, Virat is good in playing cricket. Okay, Virat is good in playing cricket, and this time he is representing our country at international level. This is also, it is a proposition. Proposition are nothing but a statements, right? Next, compound proposition. Very simple compound proposition. You are aware of the compound words, right? Water, bottle. Water, bottle. This is a compound word. Yes or no? Rose, flower. Rose, flower. This is a compound word. Now, what about the compound proposition? Two or more propositions are nothing but a compound proposition. Virat Virat is playing cricket. This is first proposition, and this time he is representing our country at international level. That is second proposition. So these type of proposition can be considered as a compound proposition. Okay, compound proposition. Next, prepositional variables. Very, very important. Okay, this is very, very important. Let me show you. Okay, prepositional variables, right? Prepositional variables. Okay, so what is our example? Virat is good at cricket. Let me take this example. Virat is good at cricket, and this time he is representing. Okay, Virat is good at cricket, and this time he is representing our country at international level. Our country at international level. You see this, to write this compound proposition, I have utilized 3 lines. Yes or no? First, second, third. Okay. Now let us simplify this. Okay. Let us simplify this. Okay. Virat is good at cricket. Virat is good at cricket. Let us replace this particular proposition with P. Next, complete. This time he is representing our country at international level. Let us represent with Q. Now read this. P and Q. As simple as that. So keep on writing. Yeah, one compound proposition, that's fine. If I'm able to write 2, 3, 4, yes or no, my time waste. Yes or no, my time waste, pen waste, everything will be waste. So that is a reason. We are using a variable that, see, we are using to represent the variable, right? That too, we are using this variable to represent the proposition. That is the reason it is known as a prepositional variable. So finally, it becomes P and Q. Now the question arises, what is and? P is a variable, fine. Q is a variable, fine. Now what is an? And is a logical connective. And is a logical connective. And is connecting 2 variables. Okay. So and this is a logical connective. Basically, we are having 6 types of logical connectives. Let us see 6 types of logical connectives. Let us learn one by one. Okay. Logical connectives. Number 1, negation. First logical connective, negation. Symbol, this is the symbol, the usage is not. Number 2, conjunction. Number 3, disjunction. Number 4, exclusive or. Conditional, biconditional. Okay, let us learn one by one. So the first one is negation. Okay, so what is a negation? Negation. Negation. Let me consider a propositional variable P. Rose is a pretty flower. Rose is a pretty flower. Rose is a pretty flower. It is a statement. Now what is a negation means? Negation of P. Negation of P is defined as, it is not the case. It is not the case that P or not P, in simple manner, or not P. Okay, so what is our example? Rose is a pretty flower. Now how to negate this? It is not the case that Rose is a pretty flower. Or simply rose is not a pretty flower. Rose is not a pretty flower. pretty flower. Okay. P. Negation of P is a preposition. Okay, prepositional way. Negation means just reverse that. Okay. So usually negation is having a two symbols. We can represent like this, or sometimes we can represent like this also. Okay, it is having a two symbols. Okay, now let us see the truth table. Okay, truth table. Okay, truth tables plays a very vital role. With the help of the truth tables, we can understand the things in a very easy manner. Okay, so what is our variable? P. What is our variable? P. So what is the negation of P? Like this. Sometimes we can use this symbol also, no problem. Okay. Now, if P is true, negation P is false. If P is false, negation P is true. That's it. If P is true, negation P is false. If P is false, negation P is true. P, rose is a pretty flower. Negation P, rose is not a pretty flower. Here, rose is not a pretty flower. Negation of this, rose is a pretty flower. That's it. Okay. Now let's go to the next connective. So we have finished the negation. So the next logical connective is conjunction. Conjunction. Okay, conjunction. Its symbol is like this. Usually it is used to represent and or but. Okay, and or but. Okay, so conjunction of P and Q is nothing but P and Q must be true. P and Q must be true. Then only P and Q becomes true. Then only P and Q becomes true. Else it is false. Okay. Let me explain truth table. Next we go to the example. So P, Q, P and Q. P, Q, P and Q. So true, 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 false, false, true, false, false. In a digital logic, if you say, it is like a 1 1 1 0 or 0 1 0 0, like the same. Instead of that, here I am using true true, true false, like that. Right? See. So what is so how I have defined, okay, how I have defined, in order to make this particular statement true, P must be true, Q must be true, then only it is true, else it is false, false, false. It's like a multiplication. 1 into 1, 1. Yes or no? 1 into 0, 0. 0 into 1, 0. 0 into 0, 0. Okay, we'll see the example. Okay, P. 2 is an even number. 2 is an even number. Okay, 2 is an even number. Right? Q. 2 is divisible by 2. Time being, I have taken this example. Okay, 2 is an even number. 2 is first part is true and second part is true. So both are true. Final result also true. Right? Next. Okay. Next. See, again let me write. True, false, 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 true, false, 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 false. Yes or no? So for this, 2 is an even number. Okay, 2 is an even number. 2 is an even number and 2 is divisible by 2. That's fine. 2 is divisible by 2. True. Now, second statement is like this. 2 is an even number. 2 is an even number. 2 is divisible by 3. 2 is otherwise we'll take like this. 2 is not divisible by 3. Okay. Similarly, vice versa also. So please remember one thing: P and Q become true for conjunction. Both must be true. Otherwise, it is not. Understanding? We'll go to the disjunction. Third one, disjunction. The another name for disjunction is inclusive OR. Inclusive OR. Symbol like this. Okay. Disjunction. Okay, disjunction. Okay, disjunction. Okay, let me again, let me show with the help of the truth table and give a very good example. Okay, okay. P or Q, P or Q becomes true. PRQ becomes true. Okay, PRQ becomes true when it fight opposite to the conjunction. Conjunction means P and Q becomes true when P and Q becomes true when both are true. PRQ becomes true when when any one of, okay, when I will tell in a opposite manner, try to understand. P and Q becomes true. P and Q becomes true when P, in case of conjunction, P and Q becomes true, PQ must be true. But for conjunction, if we see the disjunction, what happened, you see here, true false, it all, when then that time also it is true, false true, that time also it true. When P become false, Q become false, it will become a false. It is like a addition. It is like a addition. Understanding? If we talk in terms of a digital, 1 plus 1, 1, 1 plus 0, 1, 0 plus 1, 1, 0, 0, 0, like this. Okay, let me give you a very good example. Okay, let me consider myself as a HR. Let me consider myself as a HR of an Accenture company. If you want to get a job in my company, if you want to get a job in my company, you should have a knowledge in C++ or Java. Okay, let me consider myself as a HR of the Accenture company. If you want to get the job in my company, you should aware of C++. Otherwise you have to aware of C++ or Java. You have to aware of C++ or Java. I'm not telling both. You have to aware of C++ or Java. I will give the job. So you came to my company. I asked you the question, are you aware of C++ or Java? Now your answer is yes, ma'am. I aware of C++. I aware of C++, Java. Yes, you got the job. Second person. Second person. Ma'am, I'm aware of C++, but I didn't aware of Java. Fine. You'll get the job. Third point. Third point. Ma'am, I didn't aware of Java, but I didn't aware of C++, but I'm aware of Java. Fine. You get the job. Fourth person. Ma'am, I'm not aware of C++, not aware of Java. Get lost. Yes or no? So what is the response of a HR? You are not aware of C++, you are not aware of Java, but you dare to come to the interview. So what can you expect from the HR? Get lost. Yes or no? So this is the best example for the disjunction. So the symbol is P or Q. Okay, the symbol is P or Q. Right? Next, fourth one, it is XOR. Exclusive OR. Fourth one is exclusive OR. Okay, fourth one is exclusive OR. So P, Q, this symbol is like this, P or Q, P, Q, P or Q. So see here, the logic behind exclusive OR is, the logic behind exclusive OR is the logic behind exclusive OR is, if the both values are same, the result is false. If the both values are different, then only the result is possible. Otherwise it is not possible. Okay, during festival time we go to the shopping mall. Okay, we use it to see the offer. If you purchase a 1,000 rupees saree, we will give you a makeup kit or handbag, but not both. So this is the best example for this exclusive OR. Okay, so now till now what we have learned about the discrete mathematics, and we have learned about the logical connectors. So in the tomorrow's class we will learn about the implication and by implication. Okay, thank you.